risk measures. So what are we looking at here? So far, we've been looking at bonds where we said that compared to changes in that own bond's yield to maturity, right? Its own yield to maturity. And why I'm writing I by Y? Because in our calculators, that is what we use to calculate the yield to maturity, which is like an average rate for that bond's entire life if you are going to hold it to maturity. And we look at the bond's price based on changes in the yield to maturity, and we take a PV minus and a PV plus, right? So if interest rate goes down, what happens to the price? If interest rate goes up, what happens to the price? And based on that, we calculate your duration and convexity. Now, the problem with that is that not all bonds have a stable yield to maturity. There are bonds which don't have that type of a stable yield to maturity, and why is something I will tell you shortly. But what we do with them is, so that type of a bond, what we will do is we will look at it in terms of the curve. And what does the curve mean? The underlying benchmark, the yield curve of the benchmark rate. Let's say that is your interest rate, right? So if interest rate is changing, what is happening to the bond price? So instead of looking at the bond's yield to maturity, instead of looking at its own yield to maturity, we look at the benchmark interest rate. So we're still going to be comparing the bond price to the interest rate. It's just that we're not going to be looking at its own yield to maturity. We'll be looking at the interest rate, and that is what is meant by when we say curve based, because we're going to be looking at the yield curve, right? At the yield curve of the benchmark. And based on that, we'll be calculating curve based duration and convexity. Then the other thing, which is your key rate duration, which brings me to the yield curve. And the yield curve is usually upward sloping, right? This is what a yield curve looks like in normal times, where for different maturities, you have different levels of yields, right? So let's say this is 1 year, this is 2 year, 3 year, and so on. So here, what we have been doing previously is that we've been looking at one yield to maturity. We're not separating it in years. And what we will do with the key rate is that we will say, okay, for the 1 year part of our portfolio, what are the cash flows which are coming in that 1 year? What are the cash flows which are coming in that 2 year? What are the cash flows which are coming in that 3 year? And then we're going to see how sensitive they are to changes in this particular rate. Because for this type of an approach, you're assuming that there are parallel shifts. If interest rates are going up, they're going up in a parallel way for all the maturities. If they are coming down, they are coming down in a parallel way for all the maturities. This doesn't happen in reality. You can have the middle end going up, you can have the short end going up, you can have the long end coming down, right? So a lot of different types of yield curve shifts are there. And that's why it's important for us to realize how sensitive is our bond portfolio with respect to each different maturity. So that's why we look at the key rate duration. Now you might be feeling a little bit confused with all of this. So obviously, number one, when we go through the material, it will start becoming clearer. And number two is that this material is more covered at CFA level 2. So we're just going to have a high level introduction to this here at level 1. It will be covered in more detail in level 2. And then the last part, which is your empirical duration. So let me just give you an introduction to that before we jump into the detailed coverage of all of this material. So empirical duration, empirical, the word itself means based on actual data, right? Empirical research or empirical evidence means based on actual data. Now, what we have been doing so far is analytical. All these durations that we have seen, they are called analytical because we're just analyzing. We're not actually taking historical bond price data and coming up with an analysis, coming up with a duration and convexity based on that actual data, that okay, what was the bond price and what was the changes in interest rate and what has been the sensitivity of the bond price to changes in interest rate based on actual data, not our analysis. So that is what we do in empirical duration. So as discussed in this learning module, we'll be first looking at calculation of duration and convexity, not based on a bond's own YTM and comparing that to its price, but instead of that, the bond's price is compared to the benchmark interest rate, right? And that is what is meant by this curve, that you take the yield curve. This is the yield curve of the benchmark, and whatever that benchmark is. Like you can take LIBOR, you can take SOFR, which is the secured overnight funds rate. You can be taking the swap rate, which is something that is discussed in more detail in derivatives. But whatever is your benchmark, in different parts of the world, you have different names for it. So, for example, in Dubai, you have something called the Emirates Interbank Offer Rate, right? IBOR. So, depending on where you are in the world and whatever is your appropriate benchmark, that is what you take for the interest rate, and you look at your bonds price changes based on that, and then you calculate your duration and convexity based on changes in the benchmark instead of the bond's own YTM, right? And then of course we're going to look at key rate duration and empirical duration versus analytical as discussed in the contents. So let's get into it. So first of all, with curve based, and why do we need to calculate curve based duration, or why do we need to calculate effective duration, is because as discussed that some bonds, their YTM is not well defined. So there are securities that do not have a well defined YTM. And why is that? So let's take an example, callable bonds. Now callable bonds, obviously you know that, let's say a bond is issued at 100 with a 10% coupon and the interest rate is also 10%, right? And it's supposed to look like this in terms of its price and changes in YTM. But if the bond is callable, let's say at 102, so even though to the downside it will look like this, but to the upside it will never go above 102. The bond will never go above 102 because it's callable, right? And what we're saying over here is, let's say the interest rate starts going down to 2%. What will happen is that this company, which initially agreed to pay a coupon of 10%, is not going to want to pay a coupon of 10% anymore, because they'll say, hey, the market interest rate has gone to 2%, right? The interest rates have gone down. The yield to maturity on this bond is going down. So why should I pay 10%? Let me call this bond back, right? Let me call this bond back and issue a new bond with a lower coupon rate. So the company will call it back, and therefore whatever is the call price that is there for that bond, then the bond price in the market will never go above that call price. And with respect to a puttable bond, what happens is that a normal bond looks like this, and let's say a bond is puttable at 999, right? And the 100 price was at 10%, and when it goes to 11%, when the yield in the market is rising, when the yield to maturity is rising and the coupon is still paying that 10%, that bond is still paying that coupon of 10%, but interest rate in the market starts going up. Interest rate in the market starts going up. You are not going to be happy with that 10%. You'll say, let me put this bond back. Let me put this bond back because it is puttable at 99, which means you as the investor can put it back to the company and take your 99, right? And then you can invest it at the higher interest rate available in the market. So this bond actually never goes below that puttable price, right? So that's what happens with callable and puttable bonds. And because of that, since their future cash flows are uncertain because the bond might be called back or they might be put back, therefore we cannot use their YTM because they don't have a well defined YTM to calculate their convexity and duration. So what we do is we instead use a change, instead of change in YTM, we use a change in the curve. Now, what is meant by the curve? Yes, it is the benchmark yield, the benchmark interest rate, right? Instead of the bond's own yield to maturity. Now, this is how you calculate your effective duration. Very, very straightforward. You take the curve, right? You take the benchmark interest rate over here. So this is your benchmark interest rate, benchmark rate. This is the price, right? And again, what you're doing is you're going to take a PV minus and you're going to take a PV plus, right? And essentially what you're doing is you're trying to draw this line between these 2 points and you're trying to get the slope of that line. Now, I don't know how many of you remember from your high school maths that gradient was calculated as y2 minus y1 over x2 minus x1, but that's what is the formula in school that we studied to get the gradient, to get the slope, right? And this is your y2, right? And this is your y1. So PV minus is your y2 and PV plus is your y1. And then again, in terms of the change in yield, so it is going up and down. So that's why you're multiplying it by 2 because you get that entire distance. So you get that entire distance. This is basically what you're doing is you're calculating the rise over run, right? That's how you calculate the slope. So when you do PV minus PV plus, that's the rise, divided by this entire thing from one end to the other. So whatever is the yield curve change on both sides, you just multiply it by 2 to get the entire run. And then this gives you the slope. But then, as you remember, duration is for a 1% change in YTM, right? It was giving you the 1% change in price. So again, this is not YTM that we're dealing with. We're dealing with the curve over here. But either way, we want it as a percentage of price. So that's why we also divide it by price to get this change, this slope, in terms of a percentage of the price. That if 1% is a change in the interest rate, then what will be the percentage change in price? So that is why we divide it by the price to get it as a percentage of the price. And this is the exact same formula we saw for approximate duration. The only difference is that instead of change in YTM, we have change in curve. Otherwise, this formula is exactly the same as your approximate duration formula. Now, as always, here is a question to help you understand this concept in a very good way. Now, I know this question is not related to a callable bond or a puttable bond, but it is related to a pension portfolio, right? And actually, it's not the pension portfolio, it is pension liabilities. Now, what does that mean? It means a company has employees, right? And they have to pay pension to their employees, and they are worried about what is the value of this liability, right? And it depends on a lot of factors, but one of the key things is interest rate. Now, usually you hire outside consultants like actuaries who are licensed at doing this. So this company is hiring an actuarial consultant and they are telling them this data. Now, don't worry about the story too much. Focus on the data. And what I want you to do is calculate the effective duration of this this liability, right? And just to make it easy for you, I've reproduced the formula here. So what I want you to focus on is just take this data and plug it into the formula and just get your sort of hands dirty a little bit with the calculation, calculate the effective duration of this pension liability. Right. So hopefully you were able to do it, right? You plugged in the data where when its interest rate is going down, the PV minus is 10.5, and then the interest rate is going up. Sorry, when interest rate is going down, your PV minus is 10.5, and then when the interest rate is going up, your PV plus is 9. And as you can see clearly, it is falling by 1.5 million. That's a lot, right? 1.5 million on a base of 10 million is 15%. And how much has your interest rate changed? Well, it is changing zero point 0.5 there and 0.5 here. So total it has changed 1%. So what we are seeing is that it is a 15% change in your portfolio for a 1% change in YTM, right? From top to bottom, if you see what's the entire change between from here 10.5 to 9, that is 15% on a base of 10, and this is also total. If you add the two, zero point 0.5, well, when I say 0.5, I mean 0.5%, which is 0.005 in decimals multiplied by 2. So this is basically 1%, right? So for a 1% change, what you're seeing is a 15% change in the value of your portfolio. And why is this important to know? Because obviously, if you know now that with a 1% change in interest rate, your liability goes up by 15%, well, that's huge. And I don't know if you guys followed that whole discussion about your Silicon Valley Bank. So some time back, there was a problem with this bank, Silicon Valley Bank. And what happened was this bank had invested in, they had some deposits, obviously, from their depositors, and they had bought some bonds with that money, right? And again, duration is such an important measure because it tells you how much your price can go down in percentage terms if interest rates rise, right, by 1%. And that's what happened. I mean, the Federal Reserve raised the rate so fast and so much that these bonds that these banks were holding, Silicon Valley Bank, and then there was also the Signature Bank, right? Then there was First Republic. Obviously, all of this was in the US. So, First Republic and Signature Bank and Silicon Valley Bank, and then the bonds just crashed, right? They just crashed, and well, they had to be helped then by the government because the deposits were lost and people started taking their money out, so it was a big problem. But the point is, my friends, the point is that you have to understand how important duration is. And it's not just duration, obviously, you have to look at convexity as well, right? So I'll come to convexity. Let me just re explain to you the reason why we're looking at effective duration and effective convexity now, that instead of the YTM, why we are using the benchmark yield. Because for certain investments, certain portfolios, certain liabilities, it is not YTM cannot be determined with certainty, right? Because such as callable bond, you can see that if it is, let's say, callable at a price of 102, it will never go above that price. The company will call it back, right? So it is not going to display that normal behavior that we saw, right? So this is what happens with a callable bond, that it does not go above that callable price when interest rates go down. And with puttable bonds, what we have seen is that they, if let's say if this is puttable at 99, so it just stops falling and it doesn't fall below that, right? So this is what happens. Now moving on to effective convexity. So we looked at effective duration. Now we're talking about effective convexity. It is exactly the same as your approximate convexity. The only difference is that instead of taking the change in YTM, we are taking the change in curve. right? So very, very simple, straightforward. The only difference is you are taking your change in curve, and obviously this is useful for callable and puttable bonds. So puttable bonds have a convexity. Let me change the color here a little bit. So puttable bonds are also like this, but they just don't fall below a certain price because, well, they are puttable at that price, but they are still convex, right? Puttable bonds always have positive convexity, even more than your option free bonds. They are more convex, right? Now, your callable bonds, of course, are also convex, but not entirely. They are convex at the bottom end, or the high interest rate or the high yield area. But when you talk about the low yield area, what happens is that they just kind of become like this because they are callable at a certain price, so they don't go up. So what happens is, at low yields they have negative convexity. So instead of going like this, or instead of going straight, they just have negative convexity. Anyways, guys, what I want you to focus on is, again, getting your hands dirty and doing these calculations, right? So this is from the curriculum, example 1. And it's not just the calculations that I want you to do. So not only do I want you to calculate effective duration and effective convexity, which is now baby stuff for you, right? But what I want you to do is start analyzing this. So this is the statement I want you to focus on, that the portfolio manager is seeking to invest in a bond with a duration of between 7 and 8 and positive convexity. Now what I want you to do is calculate the effective convexity, calculate the effective duration, and then make a recommendation to the portfolio manager that should they go for this bond. Does it meet the requirement of a duration between 7 and 8, and does it have a positive convexity or not? So please pause the video and then let me know what you want to do in terms of your recommendation to the portfolio manager, and then I will show you the solution. Right, so hopefully you were able to get the duration and the convexity, and you also made the right recommendation that the portfolio manager should not buy this callable bond, because even though the duration is between 7 and 8, right? But the convexity is negative, and he or she is looking for a positive convexity. So therefore, we should not go for this because the convexity is negative. Right, and how we have basically applied this concept to calculate the change in price, where we take the duration adjustment and we take the convexity adjustment. So exactly like that from before, right? Where we were doing it for the approximate duration and approximate convexity, here we will just be using the effective duration and effective convexity with the change in curve instead of change in YTM. Everything else is the same. Obviously, effective duration is negative change in curve because that is obviously an inverse relationship between the price and the curve, and the convexity is always a positive adjustment, right? And it's half and squared. So please pause the video and try to solve this question, and then I will show you the solution. Right, so hopefully you were able to calculate your percentage change in price, right? You have to plug in your effective duration and your effective convexity, and then for a change of 200 basis points, which is 2%, you can calculate the change in price. And when we have been using the yield based duration and convexity, that is there, which is useful for small changes in yields, but effective duration and effective convexity is useful for both small and large changes. So this is actually very, very good. It's more useful than your approximate yield-based duration and convexity. All right, guys, so we're going to stop here, and in the next video, we're going to get into a concept which is, of course, covered in more detail at level 2, but we will have a high level overview of this in level 1 as well. So see you in the next video.